Hi, this is Mrs. Wiederholt, and welcome to my lesson video on conic sections, hyperbolas. Now let's get started. There are two types of hyperbolas, and first we're going to look at the horizontal hyperbola. Now hyperbolas and ellipses do have some similarities, but along with those similarities there are differences. Now one of the similarities is that the hyperbolas do have two axes. Now they have different names. The first axis is called the transverse axis, and it is the axis that connects the two vertices. In a horizontal hyperbola, this axis is horizontal. Now the second type of axis is the conjugate axis. It is the axis that is perpendicular to the transverse axis and goes through the center of the asymptotes, which is the center of the hyperbola. The length of this conjugate axis is determined by the b value in the equation. So why don't we go ahead and look at what the equation is. It is x minus h squared divided by a squared minus y minus k squared divided by b squared equals 1. Now if you think this equation looks similar to the equation for the ellipse, you're correct. The only difference is the operation sign right there. For the ellipse, there's a plus sign. You're adding the two fractions. With a hyperbola, you are subtracting the two fractions. Now let's talk about the different parts of this equation. First of all, we have the h and k value. And just like in the ellipse equation, the center is hk. Another similarity between the hyperbola and the ellipse is what the a value represents. The a value represents the distance between the center and the vertex. Now this is pretty much where the similarities end, because unlike the ellipse, the a value does not have to be greater than the b value. In fact, it can be less than the b value, and it can also be equal to the b value. The b value is the distance from the center to the top of the conjugate axis. And in our first example, I will show you how to determine that distance. We will also use the a and b values to determine our asymptotes. Now let's look at the vertical hyperbola. Now, a vertical hyperbola also has a transverse axis. It is the axis that connects the two vertices, just like the horizontal hyperbola. However, in this hyperbola, in the vertical hyperbola, this axis is vertical. The conjugate axis is the axis that is perpendicular to the transverse axis and goes through the asymptotes, which is the center of the hyperbola. Now let's look at its equation. Do you notice the difference between this equation and the equation for the horizontal hyperbola? The y minus k squared and the x minus h squared have switched places. With the vertical hyperbola, the a squared is the denominator of the y term. In the horizontal hyperbola, the a squared is the denominator for the x term. Now, before we move on to our example, let's talk briefly about the a and b terms again. Now, for a vertical hyperbola, the a term is still going to be the distance from the center to the vertex, and so it's going to be right there. And the b value is going to be the distance from the center to the edge of the conjugate axis. Now let's look at an example. Now in example number 1, we can see that the center is going to be 0, 0. Because if you look right here, there is no x minus another number squared. And in the y term, there's not y minus a number squared. So when you're absent of that h and k value in the equation, that means your h and k value are 0, 0. Now how do you determine the direction? This is a little different than how you would determine the direction of an ellipse. With hyperbolas, the direction is based on the positive fraction in your equation. So if we look at our example, it is x squared divided by 16 that is the positive fraction. Now, x squared represents domain, so that means it would open left and right. Now, the reason why I said that it's the positive fraction and not just the first fraction, because it is possible to have seen this written as negative y squared divided by 9 plus x squared divided by 16. In that case, the y squared, or the negative y squared divided by 9, would be first. So even though usually the positive fraction is listed first, I don't want to tell you that it's always the first fraction. It's always the positive fraction that determines the direction. So the direction for this hyperbola will be left, right. Now to find the length of the transverse axis, we take the a squared, which is 16, and we find the square root of it. Well, the square root of 16 is 4, and now we have to double that. 4 times 2 is 8. So that's the length of our transverse axis. For the conjugate axis, or the length of that conjugate axis, we're going to do the same thing. We will take the b squared value, which is 9, and take the square root of it, which would be 3, and then double it. 3 times 2 is 6. Let's go ahead and sketch a graph based on the information we have now. Our center is 0, 0, so I'm going to plot that point. I know it's going to open to the left and to the right. So for my transverse axis, remember, a squared is 16, so a is 4. So I'm going to go to the right 4, 1, 2, 3, 4, and then I'm going to go to the left 4. And so this represents the length of my transverse axis, which is 8. Now let's do the length of the conjugate axis. Okay, b squared is 9. The square root of 9 is 3. So I'm going to go up 3 from the center. 1, 2, 3. And then I'm going to go down 3 from the center. And this represents the length of 6 for my conjugate axis. Now before we sketch our curves of our hyperbola, we are going to create a rectangle. And this rectangle is going to help us know what our asymptotes are going to be. So we will then sketch our asymptotes, and then after that we will sketch the hyperbola curves. In order to sketch the rectangle, we will use the points, or our vertices, that we've just created. So your rectangle will look like this. Now what I've done is I have constructed these 4 lines that go right through my vertices, and you want them to connect, so they connect like this at each corner. Now we are ready to draw our asymptotes. Now the asymptotes will go through the center, and if you want, you can start at the center, and it has to go through each corner. So that would be one of the asymptotes. The other one would look like this, going through the corners here. So let me draw those. So do you see how I've drawn one line? Goes through that corner of my rectangle, through the center, out the opposite corner, and down. And then I have this asymptote up through one corner, through the center, and out through the other corner. Now I'm ready to sketch my curves for the hyperbola. Now remember, asymptotes are those invisible lines that your curve can get microscopically close but will never cross over. So this hyperbola will start here, and it'll work its way to what is the vertex, and then it goes down like that. So let's try that. So there's my first one, my first curve of my hyperbola. Now if you notice, it's not perfect, and that's okay, as long as the place where you put the vertex is exactly where it's supposed to go, because it is going to be hard for you to draw and then to get it to go right through the point, but just do your best. Now I'm going to sketch the other curve. And so there you have it. We have just sketched a hyperbola. Now let's go ahead and let's say what the vertices are. On my left one, I have, let's see, from the center, I'm going to go left 2, 3, 4. So it would be negative 4, 0. And then I go to the right, 1, 2, 3, 4, and it will be positive 4, 0. Now, we do not state the vertices of the conjugate axis. Now let's discuss the domain. So if we look on the left side of our graph where the curve is open-ended, that means we're going to start at negative infinity. And then notice, as this curve moves towards the right, it stops right here where x equals negative 4. Now, from here to here is empty space. I mean, our curve does not go past negative 4. It's like it jumps over and then starts here at positive 4. So we will use the union symbol to represent the space between the two curves. Now our domain picks up again right here where x is positive 4 and moves on towards the right towards infinity. So this is our domain. Now for the range, it is fairly simple. You see the open space down here, so that means it starts at negative infinity. Now I'm just going to follow one of the curves, but as you notice, it continuously goes up, and now it goes on to positive infinity. So the range is just negative infinity to positive infinity. Now let's do another example. Now in example number 2, again, in the equation there are no h and k values, therefore h and k are each 0. So our center is 0, 0. And for the direction, well, if you look, it is the y squared divided by 16 that is the positive term. So that means this is a vertical hyperbola, so the direction is up and down. Now let's determine the length of the transverse axis. Well, a squared is 16, so the square root of 16 is 4, and 4 times 2, remember we have to double the a value, so 4 times 2 is 8. Now for the length of the conjugate axis. The b squared term is 9, the square root of 9 is 3, and 3 times 2 is 6. At this point, we have enough information to sketch our graph, so let's go ahead and do so. We will start out with the center at 0, 0. And now for the length of my transverse axis, well, that will be 4 up and 4 down. So from the center, I'm going to go up 4. And then back from the center, I'll go down 4. Now for the conjugate axis, I will go to the left 3 and to the right 3, each from the center. Now I am ready to sketch my rectangle. I'm just going to go ahead and find my 4 corners that it will go to. And now I'm just going to sketch it with dashed lines. Now I am ready to sketch my asymptotes. I will start down on the left hand side. I will go up through one corner, through the center, and out the other corner. Now I'll do it again on the other side. I will start and go up through one corner, through the center, and out the other corner. Now I am ready to sketch my hyperbola curves. Now you can start on one side and go down to the vertex and back up, or you could also start at the center, kind of like we've done with parabolas, and do it that way. So here are my hyperbola curves. I went ahead and I started at the center and went up to the left, and then I went back to the center and up to the right, and then at this center down to the left, from the center down to the right. That might be the easier way to do it. Now let's name our vertices. Well, the first vertex is right here at 0, negative 4. So we've got 0, negative 4. And our second vertex is up here at 0, positive 4. And so there you go, there's our vertices. Now let's determine our domain. I'm just going to use the bottom curve as an example. So we are starting at negative infinity, and as we go towards the right, yes, we're going up and kind of back down, but now we're keeping on infinitely going towards the right. The same is true for up here. We're starting at negative infinity. Yes, we're going downward, but we're still going rightward, and we will infinitely go in the rightward direction. So it's negative infinity to positive infinity. Now for the range. As you can see, we start down here at negative infinity. We work our way up to 0, negative 4. And then it's like we skip over and we start back again at positive 4 and go upward towards infinity. So our range is from negative infinity to negative 4, and then we'll put our union symbol, and from positive 4 on to infinity. Now let's look at our third and final example. Now on this example, I would like for you to pause the video in just a few moments and try it yourself. And then you can turn the video back on and check your work against mine. Now before you pause the video, I do want to go over the h and k value, because in the last two examples our h and k values were 0, so the center was 0, 0. But in this example, our h value is negative 2 and our k value is positive 1. Therefore, the center will be negative 2, positive 1. Now, go ahead and pause the video and see how much of this you can do on your own. And when you're done, push play again and you can see if you're correct or not. So, how did you do? Well, let's go ahead and look. We've already determined our center. Did you gather that the direction would be up and down? Remember, that's because the y minus 1 squared fraction is positive, so it's up and down. So the length of the transverse axis would be the square root of 4 times 2, which is 4. The length of the conjugate axis is the square root of 16 times 2, which is 8. So if you look to the left, you can see here's my center, here are my vertices for my transverse axis, here are the vertices for my conjugate axis, and this is from where I sketched my rectangle. From there, I sketched my two asymptotes going through the center and in and out of the corners of the rectangle. After that, I sketched the curves for my hyperbolas. Here I started at the center and I went towards the right and then went back to the center and towards the left. And then for the bottom one, the one opening downward, started at the center and moved to the left, started at the center and moved towards the right. After I sketched my curves, I decided to go ahead and identify my vertices. So negative 2, negative 1 is my first one, and negative 2, 3 is my second one. And then last, the domain and range. So the domain starts at negative infinity and continuously moves towards positive infinity. And then the range starts down here at negative infinity and only goes up to where the y value is negative 1. Then it jumps over and starts back up where the y value is 3 and moves onward towards positive infinity. Well, I know that this video has been one of my longer videos, but there was a lot to go over when it comes to hyperbolas. So I hope this video has helped you understand hyperbolas a little bit better, and I look forward to working with you again. Bye-bye.